Hello everyone. This is one more question in the series of JEE kinematics problems, and this is from old KVPY question paper. And let us start the analysis of this question. See, there is a ball projected horizontally from a height at t equal to 0. So say this is some speed which we have offered for the ball in horizontal direction. Let this be some height h. Okay, and this instant we call it as a t equal to 0, and as you projected horizontally, we know it follows a parabolic path due to the gravity. And one more thing here, except gravity there is no any else force. Okay, there is no any air resistance, only gravitational force is a single force acting on the projected ball as the external force. Obviously, due to that, it experiences only one single acceleration, that is acceleration due to gravity in downward direction. Okay, now all the vectors will be allotted polarities, assuming that upward direction is positive, obviously downward direction is negative. So if this is the origin, it will be like plus y axis, so j cap, it will be minus j cap. Okay, now when this projectile projected horizontally, when it lands here, it suffers collision with the floor. That collisions are all considered as inelastic collisions where coefficient of restitution is less than 1. We know its symbolic form is small e. Okay, and this again goes in the following the projectile path, parabolic path, again suffers next collision here. So this is the first collision, it's a second collision, it's a third collision, and it's a repetitive process. It goes in this path. Here, through this situation, we are here to pick out the correct graph among the four which has been sketched between two parameters or two physical quantities. One is a vertical component of velocity of the ball versus other one is time. Vy versus time will be our target here to sketch the graph between these two. And among these four, option B is going to be correct graph. Let me explain you how it happens or why it is so. See, during this time interval, from the projected point to till landing for the first time, as initial vertical velocity is 0, it is like a freely falling body, right? We know 2D motion, we prefer to study like a combined study of 1D motion, two 1D motions like horizontal motion plus vertical motion. So vertically there is no initial velocity, so it's like a freely falling body at any intermediate point. If you notice the velocities, horizontal velocity will be undisturbed. If it is u, it is also u, and it will be vy, we call it as a gt. From help of equations of motion, one can get it. While landing also, it will have same u velocity, and vertical velocity will be best compared to the earlier components, and it will be obviously root of 2gh, right? Say it as a v. Assuming h is the dropped height, projected height is h, we will get this as a v. Now, during this time interval, from here to here, if you observe this time interval, as you notice that velocity is in downward direction, which is a negative. That means graph must be in fourth quadrant because velocity is negative. Whereas in option A, they have given velocity being in the first quadrant where velocity is positive, but the fact is velocity is negative because it's a downward direction. There itself I can delete option A in my consideration, and my work further analysis will be proceeded for checking BCD, comparing BCD graphs or BCD options. Okay, see, next interval, if I select next time interval, I'm going to work out about what happened for the ball between first bounce time to second bounce time. See, as it hits with V, it bounces with EV. who knows some fundamentals regarding the collisions, they can notice immediately vertical component immediately will be taken in upward direction with value EV, where E is less than 1. We know that for inelastic collisions there will be loss of energy in collision, and as you can say that now velocity is positive, and vertical velocity being positive, it will be keep reducing and velocity will become 0. Again it increases, and at the end of time of flight it will be again EV. Okay, so in this time interval, graph of Vyt must begin from first quadrant, because velocity is positive, again becomes 0, and then it will shift to fourth quadrant. Okay, so anyhow option A already got deleted. Let me check BCD. See here in this option D, in this slot still velocity is in fourth quadrant, graph is in fourth quadrant, which means in option D velocity is still negative, whereas velocity is positive, isn't it? So there itself I can have a chance of deleting option B. Option D also has a wrong answer. Okay, now in option C and option B they have given the same way, graph as same way, so there is no clarity about whether B or C which is right. Let me check up with the next time interval, that is the time duration between second bounce to third bounce. See, as it has hit the ground with EV speed, it bounced with E times this, that is E square V it will come, which means the velocity, vertical velocity in upward direction just after first bounce and just after second bounce, if you observe, after second bounce the value will be reduced a lot compared to the first one. So here in option C, the value of velocity is EV when it starts performing upward motion during the just after first bounce. When it started its journey in upward direction just after second bounce, its value is E square V, which is less than EV, but they have given same value, isn't it? They have initiated this graph also starting from same level. That itself a wrong thing. So here I have a chance of deleting even option C as a wrong one. And here if you observe, it is representing your EV, and this graph has started bit lesser height from that of this compared to this one, which means they have followed the idea that it is representing E square V, which is less than EV. Hence I can say option B is going to be a correct one. Okay, and personally I noticed that a little bit correction or modification required in option B is what? See, we know velocity versus time graph area represents displacement, and above the time axis area is positive, below the time axis area is negative. When we consider the study about the displacement, that is vectorial steady purpose, we follow the sign convention. See here, during first bounce to second bounce, what is the vertical displacement in this time of flight? Means anyone will say the answer as 0. That means net displacement must be 0. So this area and this area, I'm talking about option B now, this area and this area must be of, look wise they should be of representing same space, which they have not followed that much correctly here. Okay, as well as here also during second bounce to third bounce, during this time of flight, as vertical displacement again is 0, that means this area and this area must also be of same one, isn't it? This way you can notice the small correction, and it is a worth question giving revision of many basics of mechanics concepts. Hope so you understood this in a proper way. Thank you.